Finally found a calculator that actually uses base 12 and actually works. And it took a fair amount of time, unfortunately. Most of the sites that I went to don't actually work, but if I divide 1 divided by 3 in a normal base 10 system, it's non-terminating because I'm trying to put 3 into 10. And because 10 is not divisible by 3, then that fraction, 1/3, doesn't terminate because it doesn't ever completely fit the base 10 system in which I'm trying to do the division. But if I instead change this to a base 12 system and I have the exact same operation, it gives me a terminating answer of 0.4. So that's because 1/3 of 12 is 0.4, right? It goes in 4 times. 3 goes into 12 4 times, and so 1 divided by 3 in a base 12 system is the same thing as asking how many times does 3 go into 12? It goes in 4 times. So if I take 1/12 and I divide it by 3, then I've got 4 parts. So 0.4. So that fraction terminates because 3 goes into 12 4 times evenly. And so the only time that we run into this problem where we're trying to get 1 divided by 3, but we get this weird non-terminating answer is because 3 doesn't go into 10, but it does go into 12. And so the only reason that that's really important is it's not saying that there are no odd fractions that exist in a base 10 system. It's not saying that it's an error. It's saying that from the perspective or within the framework of base 10, where the consistency, the texture of this operation is slightly different because it's got different ingredients in it. It's kind of like putting a pineapple on pizza instead of on a fruit salad. It's still a pineapple, but it's going to taste a little bit different because of the context in which it's being placed. So it isn't really breaking math to say that you have to add 0.00001 in order to get it to actually go through. That's not necessary unless the base system that I'm using doesn't break evenly into thirds or whatever fraction that I'm using. So you don't have to. What I was getting at with the periphery and all that stuff with that magical insert, that happens because of the base that I'm using. If the base is 10 and I divide 1/10 by 3 parts, then it's describing what it would be like if I took a whole unit, which is 10, I take one of those whole units and I break it into parts. So it just gets us to focus on what the operation is actually doing. It's taking one whole unit, which in a base 10 system is equivalent to 10, and it's dividing it by the number of parts, equal parts, that it has. In the case of 1/3, in a base 10 system, I'm dividing one whole unit, which is a value of 10, divided into 3 parts, which is what gives me the 0.333333 repeating. And the reason that it gives me the 0 is because even though I'm taking 1/10, one whole unit, which is valued at 10 because it's a base 10 system, the reason that if I divide that 10 into 3 parts, I don't get, the reason that I don't get a whole value at the end is because of the difference between a whole and parts. And that's what the operation is actually describing and defining, are the limits between the parts and the whole. And the reason that that operation is so interesting in a base 10 system versus a base 12 system is because of the unit of which we're dividing. So normally we don't think about that because we just think that base 10 is like math and then base 12 would be some weird exotic thing. But base 12 is no more or less exotic than base 10. It's still math. It's the exact same information. It's just being represented differently. And the difference in those representations then draws our attention to what is actually happening. And what is actually happening is we're taking a whole unit and we're dividing it into parts. In a base 10 system, we're dividing a value of 10 as one whole unit. In a base 12 system, we're still dividing a whole unit, but in the base 12 system, that whole unit is 12 digits long, or 12 values away from 0. So the question of why is it the case that we have to add that 0.00001 in order to get the 3/3 to equal 1 is not because there's some problem with mathematics, but rather because there's a problem with trying to divide the number 10 by the number 3. So all it's saying is that the answer won't fit inside the frame. It's kind of like trying to take a picture of something that's bigger than the camera lens resolution. It's like if I was going to try to take a picture of something that was right in front of the camera, it's going to be out of focus. It's going to be all blurry. I'm not going to be able to see it. It's going to be kind of indiscernible, fuzzy, because the resolution is out of whack. It's not aligned with the thing that I'm trying to take a picture of. Whereas if I get a bigger resolution, then I'll get more pixels, and because I get more pixels, I get a finer cut of the final image, and so it enhances the way that the representation of what is being imaged is, but it's not changing what actually is. And that's why in a base 10 system, 1/3 is equivalent to a non-terminating fraction, and yet the same exact operation has a terminating fraction in base 12. And I don't have to add anything at the end because the frame is large enough that I can fit enough pixels in it that I can get a clean image of what is already always the case.